Now let's talk about method resolution order. Okay. By now we know that when you ask for some object dot attribute, an attribute is not found in that object, Python starts searching in that class that some object was created from. If it's not there either, Python searches up inherit chains until either attribute is found or the object class is reached. This is quite simple to understand if the inherent chain is only composed of a single inherent step, which means that classes have only one parent. However, when multiple inherent is involved, there are cases where it's not straightforward to predict what will be the next class that will be searched for if an attribute is not found. Python provides a way to always know the order in which classes are searched on attribute lookup, the method resolution order, okay, or MRO. So let's see it. We will use our file class inherit.py. I wanna comment this line. Okay, print, and now you will call something like this. And in this case, I wanna try with square. The square object dot class okay, square dot class and dot underscore m or o. Okay, you just see it and just run it in a new terminal, of course. Py OOP method and multiple. I always see something like this. What we've got here, and we are looking this part: a square, then regular polygon. Okay, I wanna move this graph to here in order to see what we are going, where we are going. So okay. Square, then regular polygon here, and then polygon, okay, here, then shape, okay, plotter, and class object, okay, here. Okay, so let's remove this line here. It's taking this part, okay. Note that the only point of doubt is the bisection after polygon, where the inherent chain breaks into two ways. One leads to shape and the other to plotter. We know by the scanning the MRO, method resolution order, for the square class that shape is searched before plotter. Okay, the shape class is searched before plotter. Yeah, that's it, and nothing more. So now let's continue with class and static methods. Okay, class and static methods. So far, we have coded classes with attributes in the form of data instances methods, but there are two other types of methods that we can place inside a class. What are called static methods and class methods. Okay. Static methods, by the way, as you may recall, when you can create a class object, Python assigns a name to it. That name acts as a namespace, and sometimes it makes sense to group functionalities under it. Static methods are perfect for this use case since, unlike instance methods, they are not passed any special argument. Let's look at an example of an imaginary string util class. So I'm gonna close this one, and now let's create a new file called static methods. Static methods .py. Okay, methods.py. As I told you, I wanna create a class called string util. Okay, it's not this class with double S. Now let's say static methods. Let's define a method called isPalindrome. But in the next line is palindrome. Okay, this is the set parameters case. Intensity equal to true as a default value. Now let's say s is equal to empty string to dot join c for c in s if c is one number. Now let's check if case intensity is true. S equal to s dot lower. Okay. And therefore in range length s, just length s, if s c different from s c minus 1, return false, otherwise return true. In the same way, let's create another static method called def get unique words. It will receive sentence, returns, and probably you recall the method set dot split. Okay. So let's try it. Print string util dot is palindrome. I wanna say radar case intensity equal to false. And this is our first test. Now string util dot is palindrome, and you can say a not for a jar of tuna. Then print string util dot is palindrome, never odd, comma, or even. Okay. I wanna add some tests more, like print string util dot is palindrome, but in this case I wanna say in 0 I must not add consuming more int. This is Latin. And print string util dot get unique words from the word I love palindromes dot I really love them. Okay, if everything is okay, let's try it. So static methods, and we've got an error here, which is an attribute is unknown. Yes, this is the method is unknown. Okay, let's clear and let's try again. Okay, you will got another error, which is a not length method. Well, also remember that it's divided by 2. Okay, this one here is lower. Okay, let's clear again. Now let's try it. Okay, something wrong here. I was not expecting fault here because missing here is -c. Okay, let's start again. Clear and let's try it. Okay, now we've got false, true, also false. Let's check this. Is not palindrome by this exclamation symbol or not? It's even. Okay, let's see even like this. Okay, let's true. That we're expecting true and false the first one. Okay, because false because it's case intensive error. Now the second one, of course, it's a palindrome, never odd or even is palindrome also. Gyronimus not consuming this Latin sentence also is a palindrome. We have got palindrome here. We have got I love really them as a unique words. Okay, so very important here. This line we are removing characters like exclamation or other kind of symbols that is not important in this exercise. We are comparing just let's has. Okay, case intensive in order to lower our sentence. Okay, make it lowercase. In this line we are comparing from the first word to the last word. Okay, the same way the second word to the previous last word. Okay, and in this line or this block of code we're comparing the sentence. We are comparing A to the last word. We're comparing this word with this word. Okay, in this way, U with U and T with T, in this way until I reach the middle of the sentence. Okay, in case of the comparison is not equal, we are returning false. In other case we are returning true, affirming or making sure that our sentence is a palindrome, okay?